So this isn't going to be a podcast for everyone. This is going to get pretty nerdy pretty fast. A, the person that has the cheap bike, and B, the person like me who has a really nice bike at the moment, like I'm rocking the
worse than CO2 greenhouse gas causing thing that's literally there so that for 5 or 10 seconds it can transport the cancer-causing PFAS chemical into your chain and then evaporate, instantly becoming a greenhouse gas. I mean, I just look at these products, you shouldn't even be allowed to sell this crap. You know, with our super secret product that we launched was the first pure wax with a solid additive that would actually fully penetrate the chain. It's one of those feel-good moments of like everything we did in the lab actually worked in the real world. In theory, you're losing that ring and you're losing that. It feels like a big savings, but that's a really dirty, turbulent area of the bike that I think just the Aero effects are reduced because there's just so much nastiness going on as compared to...
Josh, welcome back to the Roadman Cycling Podcast.
Hey, thank you for having me.
So this isn't going to be a podcast for everyone. This is going to get pretty nerdy pretty fast. You're in that elite club of repeat return interviewees.
Ooh, it's very exciting.
Elusive club.
Elusive. Well, I am honored.
I'm not sure if it's a good thing. I wanted to go with a little bit of a Pimp My Ride concept today. I have two beautiful bikes, actually more than two beautiful bikes, but two that I want to focus on today, a road bike and a gravel bike. I want to make sure that I'm getting the very most out of them. And I know there's a bunch of listeners, because I get DMs over on Twitter all the time, and they get a nice bike and then they're worried that they've done all the wrong things just because they're simply overwhelmed, that they've done all the wrong things with the wrong tires, the wrong chain lube, and they worry that they could have got a bike for multiples cheaper. They could have got like a €1,500 bike instead of a $15,000 bike and actually gone faster if they had a bit more knowledge. So I want to give those two types of people. A, the person that has the cheap bike who wants to, get the maximum out of it. And B, the person like me who has a really nice bike at the moment, like I'm rocking the Factor Ostro Van. How can I get the most out of that too?
Okay.
Let's start on drivetrain and drivetrain efficiency, because this for me is an area where I'm most overwhelmed. If I go into my local bike shop, and I know you guys have talked on your podcast ad nauseum about lubes and waxes, and talked for longer than I ever knew was possible about the differences between like wet lubes and dry waxes and various viscosities. It's actually amazing how long you can talk on that topic. But when I go into the bike shop, this just causes me so much overwhelm because there's not really an objective standard of what is fastest. We use just terms like wet and dry, but I don't think, maybe it's just me that's overwhelmed. I don't really feel like anyone has an idea what's a fast lube and what's not.
Yeah, no, you're totally accurate. I mean, there's some good data and science out on the internet, and unfortunately, I think for us, the gold standard was Friction Facts out of Boulder, Colorado, and then they were purchased by Ceramic Speed. And so their free and unbiased data ended, 5-6 years ago, and is still out there, but technology has moved on. And so, we've got bits and pieces. You look at our site, we've posted some things that Tour Magazine has done in Germany, and a number of other independent bodies have done some testing and posted it. But, of course, if Silka's going to post our own testing, of course, we're going to be the fastest, right? Right. And so we try to do it, and every company is that way, right? We're all, and I don't even think in a lot of cases, it's not even that the companies are lying to you. It's that, you have a test machine and you develop a lube to be the fastest on that test machine. That doesn't necessarily mean that it's going to be the fastest on the other. It's a little bit like wind tunnel testing, right? It's not so much that people are likely lying to you. It's just that they're designing product to fit the test that they have. And because every test is a little different, there's variables, right, that you can...
Yeah, we talked about this last time where, a company goes in looking for an outcome that they want to prove that, hey, we have the fastest frame out there. So they'll go in and they'll just use a bunch of different yaw angles until they confirm the hypothesis that they went in with.
Yeah, that happens too, right? And so that's what I would say, that's testing and not development. I think what I'm talking about, and that to me, taking your complete bike to the wind tunnel and then doing stuff until it's the fastest, that's sketchy. Come on, guys, that sucks. But in terms of like true development, every wind tunnel is different. And so if you're in there and you're developing the product in real time and making changes in real time, you are unwittingly and really unknowingly, you're building in things specific to that tunnel. I mean, it's a little bit like look at Mercedes in Formula One right now, right? I mean, they've designed this car last year that, they just thought was going to be magic, and it was super radical. And what ended up happening was they had built in all this testing bias between their computational models and their wind tunnel models. And when they actually go to race the car sucks. And it's not that they tried to build a car that sucks, and it's not that they were even lying to themselves. They legitimately thought they were building a fast car. They just weren't, because of this testing bias situation. So that's something to think about. But back to your original question. I think, this space is full of total nonsense, and it's full of really antiquated companies making a lot of money selling you a lot of garbage. I guess for starters, the whole like wet versus dry lube is funny. Some companies, it's like, oh no, this lube is wet, like it's oil-based, and this lube is dry, like it dries. And then other companies say, no, this is dry conditions lube, and this is wet conditions lube.
Yeah.
My rule of thumb there is that dry lube as a category is absolute garbage, and you should never even consider buying it. And beyond garbage, they're all little like environmental hand grenades, right? I mean, most of these companies selling this crap, it's just terrible, toxic stuff, right? And we're one of the first to make a real environmental statement about lubricants and say we're not going to use any of these chemicals that are really bad for the environment or bad for human health or animal health. And yet you have companies still doing it, right? And so if we're going to name names, which I get in trouble for doing sometimes, but you look at the Finish Line products or the White Lightning products, these are toxic, cancer-causing PFAS chemicals, which are on their way to being banned, thank God, in California and in a lot of Europe, but they're terrible chemicals, maybe 10 to 15% of total. And then they're in a solvent like a pentane or a heptane or some worse than CO2 greenhouse gas causing thing that's literally there so that for 5 or 10 seconds, it can transport the cancer-causing PFAS chemical into your chain and then evaporate, instantly becoming a greenhouse gas. I mean, I just look at these products, you shouldn't even be allowed to sell this crap.
But so maybe, Josh, to as a way to approach this question, to reverse engineer it and think, so what does make a fast chain lube? And even back to, friction 101, what is the function of effective chain lube?
The function of a chain lube is to fill the negative space inside the chain with something lubricious that under pressure can keep the metal from contacting the other metal, right? In an ideal world, you'd have this little like wedge of lubricant that even under pressure is essentially keeping the metal from sliding against itself. And in the theoretical roller chain, you have what they would call like a point contact, and all of the points aren't sliding, they're actually rolling against each other. And then you have this lubricant in there because you think you've got this sort of like point rolling friction that ultimately becomes sliding friction in most cases. And then you have the side plates, which are always sliding next to each other as the chain articulates through the drivetrain. And so the lubricant's there to really form a barrier between those and prevent this metal on metal contact. And that's why that Adam Caron at Zero Friction Cycling, the test that he does that just looks at wear is also pretty indicative of efficiency in the chain, because if there's no wear in the chain, there's almost certainly less friction because there's no metal on metal contact. What his test doesn't capture is that, maybe one lubricant is equal to another at 3 or 4 times the viscosity. And so that lube will have more viscous friction than the other lubricant, but they may have the same wear. But there's no way that you can have a chain that wears out in 1,000 kilometers and have that be a fast chain lube, because the chain is wearing out because metal is scraping against metal. There's no way in hell that can be fast. So that's ideally what the lubricant is doing. And so you get to these lubricant families, we just talked about dry lube. A way to think of it is, you've got all the negative space, particularly the negative space between the roller and the side plates, or the pin and the side plates. That's where all the real friction is coming from. You've got these little gaps, and what you ideally want lubricant to do is fill up those gaps to keep the metal from touching the other metal. And with something like a dry lube, you're maybe 10% lube and 90% carrier that evaporates. And so you have this little bit of negative space. At best, you're 10% filling that up. Which is why those products don't tend to last very long. And then also, if you're in the rain or dirt comes in, the dirt and the water can get into those negative spaces. It's probably the easiest way to think about it, right? And so, you go to an oil-based lube, or what most companies would call a wet lube. And now you can 100% fill that negative space with an oil and whatever ingredients are in the oil. And that works much better than a dry lube. But because the oil, as the chain articulates, the oil is kind of stirred amongst itself, that dirt landing on the chain on the outside can be stirred into the inside of the chain. And so, these lubricants in a clean, dry laboratory environment can be incredibly efficient and last a very long time. But as soon as they start to get dirty, they carry contaminants down into the pins and rollers.
And I guess that's a challenge if you're re-lubing on the go in a gravel race, which you see a lot of people doing. You're at likely risk of bringing dirt down into the drivetrain.
Yeah, and just the act of riding is actually pulling it in there. You think of like as the chain articulates through, particularly around the pulleys, a lot of these, you have like 10, 11, 12 teeth in a pulley. So, I mean, you have a lot of, you can have as high as like 30 degrees of articulation as the chain goes over the pulley. And so as it's articulating, right, it's literally stirring itself viscously. It's like a viscous stirring action that's going to pull all that stuff into the inside. And so, yeah, for like gravel racing relube with wet lube, you actually, the sad thing is you want to wipe the chain real quick with a microfiber towel and then add a bunch of wet lube to it and then wipe it again with the towel. Because the more you add, the more it's going to kind of flush through whatever dirt that's in there, but you don't want lube on the outside of the chain, and I think that's, sadly for the industry, that was a thing that Muck-Off sort of made famous with this little UV light that they have that, you coat it until the chain turns pink under this UV light, but that's really just coating the chain with this sticky substance that's going to allow all the dirt that gets on it to attach. What you really want to do is lube it really good and then wipe all that. The lube on the outside of the chain does nothing. Yeah, so for like a mid gravel race relube, that's your best, your best option is a wet lube because it doesn't have any drying time, and it also typically has the ability to flush some stuff out. There's a lot of products out there that claim to clean and lubricate at the same time. And, these are typically oil lubes or dry, like PTFE or PTFE and wax lubes that have solvents in them. And if you look at the zero friction data from Adam Kieran, he's basically proven that none of these work. They're all actually somewhat effective as cleaners, but they all are terrible as lubricants. And so if it says, on the bottle that it lubes and cleans at the same time, put it back on the shelf because that's just a lie. And it's a proven lie. And I think, at some level, it's the holy grail. I'm not going to say that I haven't experimented with hundreds of versions of this in our own laboratory trying to figure out if it's possible. And I've never been able to do it any better than any of the companies that are selling it. It just doesn't work.
The industry seems to be kind of scrambling to, like, there's a recognition on the one hand that waxing a chain seems to be the fastest way to go, but then there's the inherent hassle and hardship of taking your chain off, having, some sort of cooker to melt the wax. Mm-hmm. Everybody hasn't got the skills also to take a chain off and put a chain on. So the industry seems to be kind of scrambling to figure out, can they create something like Ceramic Speed's UFO, where you can have something that you can drip on, which gives the effect of wax. Would that be a fair synopsis of what's going on with it at the moment?
Yeah, I mean, I think that's the most exciting thing in this space, and I think where you've seen a real arms race. Our product, so Ceramic Speed had UFO, which was the fastest lubricant in the market, and it was a drip-on wax base that I believe in its original form had like a fluoropolymer additive to it, which is not the most environmentally friendly. With our super secret product that we launched kind of right at the beginning of COVID, was the first pure wax with a solid additive, tungsten disulfide in our case, that would actually fully penetrate the chain. And so if you read Adam's report on it at Zero Friction, it's one of those feel good moments of like everything we did in the lab actually worked in the real world. First to penetrate. I mean, we just kicked everybody's butt in terms of both friction and chain wear. But of course, when you do that, you now teach the world how to do it. And so within the next year, I think we've had 3 companies essentially do what we were doing. And so, today you can get the new UFO 2.0, or I think they're on 3.0 now, is a very similar wax base to what we've done to solve the penetration problem with a different additive than we have. So you've got, of course, I'm going to talk about my stuff, but you don't have to buy my stuff. So I got the ceramic stuff is really good. Affetto Mariposa has a product that's really good. And there's a brand called True Tension that also has a product that's pretty good. And all of those are going to get you somewhere in the 75% of the performance of hot wax sort of level.
And so what's the protocol for if you are using one of these? So how many rides are you getting out of it before you need to reapply it? And then when you are reapplying it, what's the protocol for cleaning the chain?
Yeah, it depends on the brand. For ours and the ceramic speed one, well, for those three products, you're probably looking at 200 to 300 kilometers between applications. And sort of your ideal setup, you want to strip the chain. And actually, by the time this runs, it will have launched. But we're actually just launching a product that's a chain stripper, and it'll be the first, to my knowledge, product that you'll actually be able to strip the factory grease off a chain on the bike in about 10 minutes. I mean, it's a really cool technology there. So you want to get the chain completely stripped of factory grease and clean, and then ideally with these emulsion drip waxes, you want to add a drop per roller, let it soak in and dry. You think of the mechanics here are that they're all between like 30 and 40% carrier, right? So instead of like a dry lube, which is 90% carrier, Super Secret's a 30% carrier. But that still means that when it cures, your empty space in the chain is only 70% full of wax. And then because they're little microspheres of wax, they will compress when you ride them. And so like what we recommend a process that's apply it, let it dry overnight, and then after each of your first two rides, do another light application of it, because that 70% compresses to say 60%. You add another application, that'll fill it back to 100%, but then 30% of that will evaporate, which probably leaves you in the 90% range. And then after your second ride, you can apply it again, and you probably end up somewhere in the mid 90% full of wax. And then that's going to go to 200 to 300K, add it again, 200 to 300K. Keep going. And then the beauty of these wax products is that, they're all like food safe, medical safe waxes. I know, I don't know the additives that everybody's using, but like we use a tungsten disulfide is like a Bureau of Land Management approved for painting boat hulls and bridge moorings and things. It's a totally bio-neutral additive that's also incredibly low friction. But the beauty of these is that once you've cleaned the chain the first time, you never need solvents again. And so like if you want to clean your wax chain, you can literally just get a kettle of boiling water and just pour boiling water over the chain, and the wax and all the dirt melts and falls out.
That's awesome.
And then you just add more wax. And so now that like with this chain stripping product that we've developed, it's also a biosafe organic chemical that's not a volatile solvent like a lot of the solvents traditionally used to strip a chain.
Yeah, because some of the old school mechanics would use diesel or petrol to strip the chains.
Yeah, that works the best, right? Historically, yeah. So we recommended the challenge with getting the grease out is you want to start with grease is non-polar. And so like dissolves like. And so you want to start with a non-polar solvent like a mineral spirits or diesel or gasoline. I mean, one of these, some pretty bad stuff. And then you want to move towards a polar solvent. You think water is polar. You want to move to a polar solvent so that you can remove any residue from the non-polar, because you want bare metal for the wax to stick to. And so that's the challenge. A lot of these, our method is 2 chemicals. I think Adam's method is 3 chemicals. And some of those processes can take a day or 2 days to really get the chain stripped. And so that was, I would say, the big negative, both in time and hassle and cost and environmental, was stripping the chain. But then once you're on a wax, it's far and away the fastest, most efficient. It's the quietest. Your chains will last longer.
When you say the fastest, do you have data on
cassettes
how
will last
much
longer?
When you say the fastest, do you have data on how much faster it is in terms of watt savings?
Yeah, the best place to point you to there is Tour Magazine Germany did a big chain lube test, and they found on their machine, fastest lubricant, I think out of 30 or 40 lubricants, was this Rohloff oil. And then when they went to test wax chains, they started with the Rohloff oil, and then they did us, Molten Speed, a couple other brands. They did plain paraffin, and every one of the wax lubricants beat the Rohloff oil that had been the fastest in their original test. And in that particular test, the fastest was our hot melt, followed by our Super Secret. I think Molten Speed and Ceramic Speed were 3rd, 4th. And then the worst of the wax products was just plain paraffin wax with no additives in it. But that was still, I think, a couple tenths of a watt faster than the Rohloff oil. So I don't have the data in front of me, but I think on total we were about 3 watts. The fast oil was somewhere in the 5 and change watts of loss on a 250 watt input, and we were like 3 watts of loss on the similar input. So call it 2.5 watts improvement.
Yeah, and this mightn't sound a lot, but we're going to move on now to talk about like stuff like cross chain and one boys. and there's savings there. And then you can compound those with some savings on tires, which we'll get onto, some savings on handlebar shapes. And they all start adding up with 3 watts here, 5 watts here. I think for anyone who's a competitive racer, the important thing to remember is a lot of these tests, like you said there, that's at 250 watts. If you're in a break and you're trying to make separation at, 600 watts for a minute to get that big separation, this starts becoming the difference between, hey, I got separation and I didn't get separation.
Totally. Yeah, totally. Yeah, I mean, the way to think of these frictional losses is that they're percentage of input based, right? So if, we're 3 watts, so that's a little over 1% on a 250 watt input. But, some of these, and some of these dry lubricants, I mean, I think in the test, I think the White Lightning product was like 11 or 12 watts of loss on 250.
Oh, that's brutal.
So, at 500 watts, you double that. I mean, that, those are big numbers. And the other point of reference I like to use here is, we talk about the oversized pulley system. The best of those is about a 1.5 to a 1.8 watt savings. And so to put it in kind of perspective, a hot melt wax probably buys you a half of a oversized pulley system savings compared to an emulsion wax like our super secret product or the ceramic speed product. And those are probably buying you the other half of that pulley system. But then a poor choice in watts, I mean, the dry lubricant products, they can cost you 4 or 5 times, 4 or 5 oversized pulley systems worth of watts. So, just to put it in perspective, people, especially when you think of like the money people are willing to spend on some things versus others, it's pretty hard to beat the savings per dollar that you're going to find looking at lubricants.
So I've got my lubricant boxed off. I'm going to wax up the chain on a nice Dura-Ace chain. Now I want to move on my factor road bike. I'm running a 2x setup with a 4835 and it's 12 speed. So I'm running a 10 on the back, and I know you're going to absolutely hammer this idea of a 10 on the back, because I think I've heard you speak it previously saying there's like
10. 8 to 10.
Yeah. Is there like a 2 watt difference between the 10 and 11?
I don't have it in front of me, but yes, you just divide 360 by the number of teeth and you get the articulation angle. And so as you get down, I mean, it really starts to grow. Yeah, I think from a 10 to a 9 is like close to 3 watts. An 11 to a 10 is like 2 watts, give or take. But then it starts to get smaller as you go up because of the angle change, right, is getting smaller relatively. So, ideal world, your smallest cog would be a 12 in my world. I've teased with Shimano forever, I want like a 1423 straight block. and then just run bigger rings up front, because you see a similar effect. The smaller the ring in front, the more losses. And the sort of rule of thumb on the front ring is, something on the order of like every 3 teeth is about half a watt on the front. That's obviously over a narrow range, but yeah, we've got a ton of data on this. I think we've got some stuff posted on our site about it. But yeah, if you can go +1 tooth on every cog in the back, that's probably going to save you a watt or more when you're in your small cogs. And then if you can offset that with a +3 tooth gain in the front, that's probably going to get you another half a watt. And then the other thing to think there is, I am not a huge fan of 1x for racing. I mean, I think it's killer and elegant, and it's fantastic for just riding and enjoying yourself. But, the problem with these 1x systems is that to give you a full range, they typically require these super small cogs. But then also, because you only have a single chainring position, when you're in your larger cogs in the back, you are just doing more cross-chaining. And cross-chaining, something like a big range, like a big combination, you can be 5 or 6 watts of loss just due to the cross-chaining.
Is there an argument with the 1x to say that the aerodynamic gains from losing that front mech offset the cross-chaining?
Not generally, because losing the front mech then forces you to go to a much larger rear cage to handle the massive difference across the range of the cassette. And so in theory, you're losing that ring and you're losing the derailleur hanger and the front derailleur itself. It feels like a big savings, but that's a really dirty, turbulent area of the bike that I think just the aero effects are reduced because there's just so much nastiness going on, as compared to, especially if you get a little bit of drive side yaw in the wind, having much larger derailleur cage hanging down. In most cases that I've seen, it's about equal. And I would say similarly with like oversized pulley systems, outside of like the pure aero ones, you're typically offsetting your frictional losses with aero drag increases in a lot of those products.
So in terms of commercially available chain rings, who's making the fastest setup at the moment, and what is that ratio look like on a road bike? So, I would have been coming from traditional 53-39 on the road, and now it's a 48-35 with a 10 on the back. Those sort of ratios that are going to allow me to be competitive in road races, have enough gears to climb and sprint and line outs. What would you be riding right now on my Factor?
I mean, personally, and having worked with SRAM for years, I love everybody over there. But I mean, man, those folks at Shimano just continue to kill it in these efficiency departments. So, the Dura-Ace chain continues to be more or less the fastest chain you can buy. And a little bit back to your opening, if you have an inexpensive bike that you're trying to maximize efficiency on, there's not a ton of difference between a 105 cassette and chainring, but you can probably save 2 watts by going to a Dura-Ace chain, and they're not that expensive. But, the Dura-Ace chain is on average probably 3/4 to a watt faster than the top chain of the other brands. It's a fast chain. So, I would look at that. And then, gosh, for gravel racing, I'm not a huge off the top of my head gearing chart guy, but I would go as big as you can get. I mean, if you could get a 12, a cassette in the back that starts with a 12 and then work your chain rings to go with that. I mean, you look at what we're doing with a lot of the pro peloton. I mean, the teams that we work with, half a dozen. I mean, if you look at them, they're running 60 tooth chain rings in road stages in some of these cases. And, I think a lot of the guys are running, 50, 56, 42. I mean, it's as big as we can get the companies to give us. And then that just lets them run larger cogs in the back. And I mean, hell, for time trialing, I've got a couple of athletes on like 64 and 66 tooth chain rings for time trialing, and the other thing there, thinking about the cross chaining, particularly in a time trial type situation, if it's relatively flat, we will custom build a cassette to get whatever that kind of sweet spot, 1 or 2 cogs right in the middle, so that you're having minimal chain angle coming off of that huge ring in the back, because it's watts, right? It's all watts.
And so moving on to tires and wheels. So I'm running the Black Ink 45 wheels as standard on my Factor. They did come as stock with a 28mm Goodyear tire on it. I changed that over to a 28mm GP 5000S tubeless tire. Is that the best tire for those wheels, or is there something you would say is faster in 28mm?
Oh, that tire really is kind of right at that sweet spot of it's almost the fastest tire going, but is also pretty functional in the real world, right? There's a lot of stuff out there that may be a little bit faster, but with a big increase in puncture risk. So it's pretty hard to beat. The thing I would look at there, and Continental is one of the brands, they use different molds and different preforms for each tire size. And so, this whole idea of, wider tires roll faster, that's true, but I think it's a much smaller marginal gain than most people think, because a lot of the data that built that theory came from companies in the old days, like, with tubulars, where you might have one tread mold and you're using that on 3 different widths of tire. And so what happens is, as the tire gets bigger, the percentage of sidewall gets bigger and the tire becomes faster. But if you were to, as Continental does, change the preform, the tire rubber kind of percentage-wise with tire width, then the gains become smaller. So I think, with Conti as an example, the 28 is, I think it's less than a watt faster than the 25, and the 30 is kind of similar. These aren't huge numbers. Whereas if you have like a handmade open tubular style, like the older, they're going away from this now, but like the older Vittoria tires, some of them you could actually see pretty big jumps there, because all of a sudden you had the tread from the 23 was also used on the 27, and you now just have a much smaller relative tread to the sidewall. But yeah, so on that wheel, I think that probably is a good tire. I would caliper it, for road racing, kind of my rule of 105 thing, you want the rim to be 105% of the tire width. The challenge we have anymore is that, different wheels have different inner widths. Some companies have different inner bead widths front to rear. But then also there's all of the new ETRTO standards, we still have not solved the tire width kind of to label consistency problem, right? And so some companies are saying this tire is 28 millimeters on a 17 millimeter bead width. And some are saying, well, this is on a 19 or a 21. And so essentially the number printed on the side of the tire is meaningless. And so you really want to get a set of calipers on it and just make sure that, for optimal road racing, particularly for time trialing, you really need that tire to be narrower than the rim. And that, in most cases, with these fastest of the fast tires, that's going to be a faster overall combination than having a slightly wider tire that's wider than the rim.
I had Dylan Johnson on the podcast chatting to him a couple of weeks ago, and he just loves his super wide gravel tires. Like, I'm rocking 44s on the gravel bike. I think he's rolling like 47s on the gravel bike. Reckons they're faster in almost every conditions.
Yeah, we actually just had Dylan in the wind tunnel a couple months ago, and one of the things we learned for gravel is that it's back kind of some ways back to the rule of 105. Once the tire is bigger than the rim is really just serving as more almost like as a spoke shortening device. The deep rims are a little faster because the spokes are shorter. And you're maybe controlling the flow and some of the shedding a little bit better. You almost can't see it. And so, we learned, and I think he did a video, and I think we've got a blog post up about it, but it was, every 5 millimeters was like a watt or two of aero loss. I mean, it was really fairly small. And so when you looked at it and geez, from a 35 millimeter to a 45 millimeter tire is just a couple watts of aerodynamic drag. But, you go do Chung method testing in the real world, and you find that that can be, as the road gets rougher, the advantage goes way towards the wider tire. So maybe it's a 2-watt disadvantage in aero, but it's a 10-watt advantage on a rough road surface. And so, yeah, I think a lot of what Dylan is doing and where he's going is kind of informed by a lot of the work that he's been doing with us and with Travis here and in our office. But yeah, I would say for gravel, and particularly rough gravel, wider is definitely better.